Welcome to the review of exam number 3 in Precalculus, where we'll talk about quadratic functions and more generally polynomial functions of degrees greater than 2 and rational functions and more. The first problem we're going to look at, and this is from a previous year's test, is we're going to graph this. This is a quadratic equation, so it's going to be a parabola. And we're going to answer all of these questions. We're going to fill in all of these blanks and then graph it. And I think what we'll do is fill in all the blanks first, even though some of them might be easier to determine after we have the graph completed, but it's not necessary. So let's fill in all these blanks first. Well, remember, the form of this is a nice form to have the quadratic written in. The general form would be f of x equals a times x minus h squared plus k. And in this form, the vertex would be h comma k. So what will our vertex be? Well, clearly k is going to be a 10. But what's h? If it were a minus sign, this would be x minus negative 8. So our vertex is going to be negative 8 comma 10. Just think of it as changing this sign, keeping the sign of this one the same. So negative 8 comma 10. That's the vertex, what I think of as the most important point on the graph. And remember that this is, a is negative 2, so it's going to be flipped upside down from the general, if g of x were equal to x squared, we know what that graph looks like. This is going to be flipped upside down and stretched by a factor of 2, twice as tall, so to speak, and it'll be located, instead of being at 0, 0 for the vertex, it's going to be at negative 8, comma 10. Okay, so x-intercepts. How do we always find the x-intercepts? We set f of x equal to 0. So I'm going to set negative 2 times x plus 8 squared plus 10 equal to 0. You could multiply all this out and use the quadratic formula, but it's actually easier when we have it in this form. I'm going to first write that as negative 2 times x plus 8 squared equals negative 10. So I subtracted 10 from both sides. And now I'm going to divide both sides by negative 2. And that's going to give us, let's see, x plus 8 squared equals 5. All right, so let's continue. Now we use a square root property to get rid of this exponent of 2. So we're going to get x plus 8 equals, and don't just say radical 5, it's plus or minus radical 5. So that tells us then that x is equal to negative 8 plus or minus radical 5. And that's the two x-intercepts. Negative 8 plus radical 5, negative 8 minus radical 5. All right? And notice we shouldn't be surprised that we started with negative 8 here, because the vertex has an x value of negative 8. So let's jump down right now to the axis of symmetry. This point, negative 8, 10, is going to be the tallest point, the highest point on the graph. And it's going to be a mirror image around x equals this number, x equals negative 8. Okay, so that's the vertical line that is the axis of symmetry. So we shouldn't be surprised if that's negative 8, that the two x-intercepts are negative 8 plus or minus the same number. It's kind of a mirror image there. Okay, so now let's look at the y-intercept, which is just f of 0, right? So we plug in 0, and we would get f of 0 is equal to negative 2 times 8 squared plus 10. And what is that? That would be 8 squared is 64, times negative 2 would be negative 128, plus 10 would be negative 118. So clearly, the y-intercept being negative 118, or you could write it as 0 comma negative 118 if you like, be more specific. It's clearly not going to be on our graph because our graph won't be big enough to plot this point, but we still need to write down what the y-intercept is. Okay, before we do our graphing, what is the domain of this graph? Of this function, I should say. Well, it's the same as the domain for every single quadratic, for every single polynomial. It is all real numbers. Or if you prefer, you could write that negative infinity to infinity. You don't have to write both. Either one would be fine. And the range, so I want the range from basically think of it from the lowest point to the highest point. Well, the highest point on the graph is going to be the vertex. The highest point is going to be that 10. We know it's the highest point because this is a parabola that opens downward since there's a negative number here. So it's going to have a highest point and opening downward. And that's going to be a 10 as the highest point. So the range is going to go from negative infinity up to, not negative 10, but 10. And there's a square bracket on the 10 because it actually attains that height of 10. All right, well, all that's left now is to graph it. Let's start with the vertex, negative 8, comma 10. So let me raise this up a little bit. That ought to do it. All right, so the vertex is negative 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, and up 10. 1, 2, 3, 4, 5, 6, 7, 8. All right. And, you know, we could actually consider this to be two of the points. The x-intercept, there are two of them. That's 2 points we could plot. Negative 8 plus or minus radical 5. What's radical 5 equal to? Roughly speaking, for graphing purposes, we just need it approximate. Well, radical 5 is in between radical 4 and radical 9. I chose those because we know those values. Radical 4 is 2, radical 3 is 9. It's going to be barely over 2. I'm just going to put down 2.2, but it's just a little bit more than 2. I don't recall what the first couple of decimal places are. So let's see. It's going to go negative 8 plus or minus roughly, say, 2.2. Here's negative 8 plus 2 and a little bit more, minus 2 and a little bit more. And I may be embarrassing myself. This may actually be 2.1 or 2.3 or something. I'm not sure what it is. I'll have to get a calculator out next time. You can do that. All right, so now that we've done that, let's look at 2 more points. And before I proceed, let me graph the axis of symmetry. So that's the mirror image, and notice these 2 points are mirror images of each other around this. So if I plug in one more point, like if I plug in, this is negative 8, so if I plug in negative 7, I would get the same thing as if I plug in negative 9. So we really only have to compute one more point to get one extra one for free. So let's plug in negative 7. F of negative 7 is going to give us negative 2 times, let's see, negative 7 plus 8 is 1. So 1 squared plus 10. And that's equal to negative 2, that's equal to 8. So 1 point is negative 7, 8. And I know if I plug in negative 9, I'll get the same value. So I'm going to get negative 9, comma 8, kind of for free. Here's negative, oh, what did I do wrong? It's not going to be 1, 2, 3, 4, 5, 6, 7. It's not going to be 8. If I plug in negative 7, oh, I don't know if I multiplied that by negative 2. I don't think I did. Yeah, I guess I did. Oh, I plotted the vertex incorrectly. Sorry about that. Negative, okay, I went 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, and then I should have gone up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is not the point. So now, negative 7, I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And negative 9, I go up 8 as well. Okay, so those are, that's 5 points. So we can go ahead and plot this parabola like this. Remember, it doesn't come up to a point. It's smooth as you pass through this point right here. Okay, it doesn't come up to a sharp point. All right, so that is the parabola, and this was all of the questions answered. For f of x equals -2 times x plus 8 quantity squared plus 10.